this lecture we are going to see the topic applications of integration in commerce and economics. Yes, these are quite different from other applications. This is actually part 1. Here we will discuss the terms related to commerce and economics only. First thing which we have to understand here before we go ahead is cost function and revenue function. Cost function in general is we denote it by Cx. This is two parts: variable cost and other part is fixed cost. Now when I have written here Cx, what does it mean? X is every time the level of output or number of units produced. Now here we have written Cx means C means cost is the function of X. Here independent variable is X, the level of output or the number of units produced. So obviously here we have to express the Cx in terms of some polynomial or some function which can be written in terms of X. So you will see that variable means which is always changing. That's why when Cx is written, variable cost means any expression in terms of X. Let's say for example it is x square minus 2x. So this is variable cost. And when a constant is added here, it's 5 suppose. So this is fixed cost which does not change with time. Here revenue, other function related to this topic, or I should say these are prerequisite knowledge to understand this application of integration. Revenue function. Revenue is earning when we sell level of output X or the number of units sold. This time when we say revenue as a function, so X becomes the number of units sold. In this condition, X is number of units of any item sold. Now revenue as a function, this also when we want to write, so obviously we have to express this in terms of X. In general this is equal to P into X. Now what is P here? P stands for price per unit. The price of one unit multiplied to the number of unit gives us revenue function. And finally this P, when we write price per unit, this is always expressed in terms of X. 5 minus 2x suppose I write. So finally if I want to find revenue function, this value of P in the bracket in terms of X can be substituted here and we will find 5 minus 2x multiplied to x. So final value of revenue function comes out to be 5x minus 2x square. Means yes, we see that revenue Rx is a function of x here, where x stands for number of units sold. Do not forget this P and X in an equation when they are related. This whole equation is known as demand function. So in general when we are discussing about demand function in the form of equation, it's all about the relation between price per unit P small and X. By the way, these topics in previous lectures already I have explained and they are separate to be discussed in details. Here we are discussing something else. Cx and Rx when we have written. Now obviously when they are functions of X, X is the variable here. I can differentiate Cx and Rx both with respect to X. If I differentiate Cx, I will denote it as C dash X. cost function differentiated, or I will express it like d by dx of cx, differentiation of cx with respect to x, or this is known as, in short, as an abbreviation MC. What does it stand for? This is actually marginal cost. The same process we can apply for Rx also. When Rx is differentiated, either we write R dash x or we write d by dx of Rx, or we write MR. Now MR stands for marginal revenue. What does it mean? Whenever we have a term marginal with either cost or revenue, means it's the differentiated form of the function. We have already differentiated it. So these are the basic terms required to go ahead with this application. Don't forget, here marginal cost and marginal revenue means cost differentiated and revenue differentiated. Now let's see what is the use of integration for these terms. Let's consider in some question we are provided with marginal cost. Obviously, a function in terms of x. It's 3x square minus 4x plus 1. Marginal cost, do not forget, marginal cost is equivalent to c dash x or equivalent to differentiated cost function. And question is asking to find the cost function now. From this, make cost function. Our requirement is cost function. Means cx is required. So in simple language, we will say that we have to go back to the original situation. We need to opt in the original function. So what operation was applied over cost function to get MC here? We operated using a differentiation. It's the opposite. A reverse operation is integration. That's why it makes a simple thing that Cx can be obtained using marginal cost by the integration of marginal cost with respect to x. Yes, when we integrate, we will get it reverse order as cost function. So integration of take an example, 3x square minus 4x plus 1. Here it is 3 into x cube by 3 minus 4 into x square by 2 plus integration of 1 is x, and do not forget to put the constant. Here don't get confused. This c I am using for cost function, and this c is the constant of integration. Every time we use, whenever we use indefinite integral, so this constant of integration will be used. Let us simplify, then we discuss what have we obtained. Is it a cost function completely? Let's see. 3 and 3 cancelled out. Here second cancellation, we get x cube minus 2x square plus x plus c. Recently I taught you that cost function is made up of two terms, variable cost and fixed cost. Here right from x cube to x, this is variable cost, and this constant means without x some value we have obtained here. This makes it here fixed cost. But every time when you are given this information, we need to find the cost function. So somehow we need to obtain this constant also. Then only constant function is complete. Otherwise not. I need to say we need to find what is this fixed value, fixed cost. So for this purpose we are always provided with some additional information. In the given example, suppose I say that marginal cost is so, and cost of producing 2 units is rupees 50. Why is it given? As soon as you find the cost function using the integration of marginal cost, here this additional information will be utilized to find the value of fixed cost, that is constant of integration. How? In place of this Cx, we substitute rupees 50, that is the cost of number of units 2 produced. So here we replace x everywhere by 2, that is 2 cube minus 2 into 2 square plus 2. Let me erase this variable cost abbreviation and plus c as it is. So what is the result? 50, it's 8, 2 square 4 to the 8 plus 2 plus c. Finally we get c is equal to 48. Yeah, this is the fixed cost we require. Now at this stage we can finalize the required cost function. All terms of x, they will be written as it is, means variable cost will be no change, x cube minus 2x square plus x, but fixed cost we will put as 48. This makes the complete cost function. This example we have taken and we could see that cost function can be obtained by the integration of marginal cost. So we can make it a formula. Cost function Cx is integration of marginal cost dx. This makes one formula. But suppose now there are few cases which we can additionally discuss. Here we are given this information, so we could utilize here to find the cost function and fixed cost also. In some case, suppose I say directly that other than this information, if I change it, that find the cost function if number of units produced is, let us consider some number of units as k. What is this situation about? Marginal cost is provided, number of units produced, I said replace this information, number of units produced is k. How we can use given information to find the cost function in this condition? Here we can make another formula, but this time we will utilize the concept of definite integral rather than indefinite. Think of it, when production of k units is done, means in the beginning the number of units produced is 0. So that's why we can write here cost function as 0 as the lower limit and k is the targeted value, number of units to be produced, that is upper limit, and integration of the same function marginal cost with respect to x. Obviously one example is genuine here. Let's take one example, then we discuss. Now let's see, I have taken one example randomly taken. Find the production cost when number of units produced is 100 and marginal cost is given 6x square minus 10x plus 3. Here information is different from the previous case. Here we are given the direct number of units produced, one value. How can we do? I say here you consider this value as k. Then production cost Cx can be obtained using the formula lower limit as 0, upper limit as k, integration of marginal cost, substitution of the values 0 to 100. Marginal cost is 6x square minus 10x plus 3 dx. Now we have here, this is advantage to us. Reason, because we will not get in definite integral case, we do not get the constant of integration. So that is why this evaluation will be direct. Okay. Now first integrate this function. 6 into x cube upon 3 minus 10 into x square upon 2 plus 3x. This whole function interval from 0 to 100. Cancellations. And finally we get this cost as 2x cube minus 5x square plus 3x expanded from 0 to 100. Just check. The only thing we have to do, if you have seen the topic definite integral at basic level, here we need to substitute x by upper limit first, right? Cx, here we substitute x by upper limit, 2 into 100 cube minus 5 into 100 square plus 3 into 100, and subtraction of each value will be 0. Reason because in each term it's x and the further value we need to substitute is 0. So that's why simply let us write 0. That is the advantage I was talking about. Now, evaluation. This will make it a big number, 2 followed by 6 zeros. Next, 5 followed by 4 zeros plus 300. Let me slowly calculate. No need to rush. 300, then we get 0 here, then 5, here we get 9 and 1. Check. This cost we have got is the production cost for the targeted value 100. Okay, so this is another application. Means I will not say it's different from what I said earlier, but the form has been changed. Previously we were using indefinite integral. In this case we have used definite integral. Now we will see how we apply integration in case of revenue function. That will be similar, but still we discuss first. Let's see. Now for revenue function, again to recall, marginal revenue is given. We understand well. Marginal revenue is the differentiated form of revenue function. Marginal revenue is given to us. It's 2x square plus 5x minus 10. And now I say find Rx. Rx means revenue. Do not forget the definition of revenue, because at last of this question we require its definition. That will give an understanding actually. Rx is required here. What was the definition? It's the earning actually by selling out some particular number of units, right? So Rx is required here using this marginal revenue. So we can write just like the previous case, Rx is integration of marginal revenue with respect to x, and every time we will use the same formula. Okay, now Rx integration of 2x square plus 5x minus 10 dx. Let's initiate this integration. Here it is 2 into x square integration, it is x cube by 3 plus 5 into x square by 2 minus 10x plus c. Yeah, we have got Rx and we can see no cancellation possible in these terms. But the problem is indefinite integral has given constant. How to evaluate? No information I have added. Like previous case, first example which was given of marginal cost, in that I gave you additional information. Here I said definition of Rx is needed. Now let's think of it. when in the beginning, very initial condition, no unit is sold, so the value of revenue also is 0. So we can use this information every time in case of revenue function. For x equal to 0, for x equal to 0, Rx also is 0. Means both sides, Rx we will replace by 0 and terms of x will be 0. So we get 0. This is equal to all these terms, 2 by 3 into 0 cube, 5 by 2 into 0 square, minus 10 into 0 plus c. So this way we get all these terms 0, means constant also is 0. But don't get confused or don't make it an illusion that every time its value will come 0. Not so. It depends on given information and type of function. I have taken polynomial function here for example. So that's why we are getting the value of constant as 0. Depends on condition I said. So every time you evaluate using this information. For x equal to 0 means no unit produced, no units are sold out, so no revenue is there. That's why both 0 together. So we can further finalize this revenue function Rx. It's 2 by 3 x cube plus 5 by 2 x square minus 10x, c replaced by 0. So this was a short lecture for this topic to explain the basic application of integration in commerce and economics. It's part 1, where we have seen application of integration in revenue function and cost function, finding using marginal cost and marginal revenue. I hope you have understood. Thank you.